how many of the domains are registered in the same site. And the thing to keep in mind is if more than one more than one site is hosted on the same IP address, every one of those sites is in your scope. Just because it's a different virtual host doesn't mean it's not on the same server. And your target is the server, not that virtual host. So you could say, okay, on zeroday.com, there's actually a really cool bug I can exploit, but on the main target, defcon.net, there wasn't. So keep that in mind when you're doing pen tests. Make sure you always test the virtual host, because just because the bank's virtual host is locked down doesn't mean someone else's isn't. So what does this get us? We get proxy DNS probes, zone transfers, virtual hosts for every IP address. We can get port scans. We can get trace route information. Just a gold mine of really cool information that other people are doing for us. We don't even have to put our IP address into any of their logs. So in addition to these kind of like third-party discovery techniques, there's actually some really cool tools you can use, more so techniques than tools, for finding information about a target network. For example, one of my favorites is actually just triggering SMTP bounces from the target network. If you don't know anything at all about a company except for what their domain is, just send an email to it. Just say, hey, Bob, and hopefully there's no one named Bob actually there, but you call it like bob.something, or a username that looks innocent, but it's really something you know won't exist. So send an email to that domain, look at the bounce messages coming back, and you can often determine the internal information, such as the name of the mail server they use, the internal IP address information. I'll go to an example of that here in a second. You can also brute force the vhost of an external web server. So something I see again and again is companies who will actually put their intranet site and their internal administration site on the same physical web server as their external site. And they just set up the vhost. So when you go to www.mybank.com, it serves up my bank. But if you tell it to that web server in port 80, you do get/http/1.1 host:/intranet and hit enter a couple times, it'll give you their intranet site. So don't forget about that stuff when doing pen tests. Just because the IP address, the host name in the vhost table isn't documented anywhere, try all the common ones like intranet, www, admin, things like that, and you'll find all sorts of fun things. A good example of that is Internet Explorer, Internet Information Server. So the ASP scripts that are installed by default in IIS will actually look at what the host name is and provide different data depending whether you're a local host or not. So if you do a GET request for a default IIS install for the default.asp, normally what you get is, there's no site configured here, click here to learn more about IIS, things like that. However, if you connect to it and you do host:/localhost from an external IP, you're not localhost, it'll actually give you the local start page. So a lot of times scripts are actually intelligent about what host name you're requesting and will give you different responses. So even if the website you're going to only has a single virtual host, try passing host:/localhost to it and see if you get a different response. A lot of times people do things like set up PHP error messages. So when you're local, it'll give you those error messages. But when you're not local, it won't. So keep that stuff in mind. Another way to figure out what the network is like and what software they use, what their addressing information is to send them an email from a subdomain where you control the DNS server. So create a new fake subdomain. Call it, mydomain.metasploit.com. And now send an email to them from bob@mydomain.metasploit.com. What happens when that email goes in and you send it to a non-existent address and tries to bounce back out, the internal server will then do a MX record lookup for your subdomain. And in doing so, it queries whatever its DNS server is. And that DNS server in turn queries your DNS server. So by looking at that incoming DNS request and looking at the source port, the transaction ID, things like that, the pattern of transaction IDs, if you do more than one of these, you can determine what software they use and what DNS server the internal sites are actually using. And that may be completely different than the DNS server they use for external requests. So that's a case where we'll get more into DNS attacks later on, but an entry point for things like DNS cache spoofing, things like that. And worst case, just email the users and drop them a link. Be like, hey Bob, check out this website. And then you can see where they come from. And if they come to you from some little cable modem in the middle of nowhere, they could be on a home network, they could be on a branch office, they could be at a hotel, but you still know where that guy is. So for example, there's this great company called RSA, and they're well known for their security. So much so that they registered rsasecurity.com. And if you send an email to an unknown host at unknown user at rsasecurity.com, you get this great little message coming back, which tells you exactly what software they use, the whole chain of stuff. I truncated some of it here, but you can see the internal IP address of the internal mail gateway. So anyways, it's kind of a fun example just because they talk about how great their products are and how secure they are. And most folks who actually do pen testing know how insecure a lot of RSA products can be, especially all the ACE stuff. And anyways, I won't go into it. But basically, here's an example of an internal IP of a real server, and it's probably still vulnerable now. I mean, it's their server, not mine. I'm not telling them about it. So finally, on to application discovery. Do you want to talk about this?
Sure. So if the network is the toast, applications are the butter. Every application that's available on the network is a potential entry point, whether these are internally written applications, these are commercial applications. A lot of times finding these applications is the trick to getting into a network that maybe isn't vulnerable to traditional exploits remotely. There's a lot of great tools for doing application discovery or service discovery. Everybody knows about tools like Nmap and AMAP, NICTU and Nessus. And there's a whole bunch of commercial tools which we're not going to plug here. But some things to think about is that doing your probes for application services slowly often will yield better results and definitely better stealth for your attacks. A lot of times just think about, rather than, okay, I want to know every port on every machine on the whole network, that's a ton of data to go through. Maybe you have a bug that you know works on a specific service. Scan for that one port or one service only on the network. A good example of this is this scan here for Microsoft SQL servers, one of my favorites during pen tests. And so rather than send pings across the entire network, scan hundreds of ports on all these different hosts, you're just going to find out the specific hosts that have that. And that gives you some other information, like most likely what the OS is. It's at least some kind of Windows. Okay, so in one case study where we use this kind of technique, the target had a custom in-house written IDS service. What this IDS sort of did was it detected when large numbers of connections were performed across the network. It wasn't necessarily an Nmap IDS signature so much as like too many connections to too many hosts, which is unexpected behavior on normal networks. So a standard Nmap scan would just light up alerts like crazy on this IDS system. So what we decided to do was, well, we'll do a slow scan, one port only, on a bunch of different random hosts, and the IDS never detected us. A lot of times you get information too, like if port 22 is open, in general it's some kind of Unix. If port 139 is open, in general it's Windows or Samba server of some sort. So rather than doing these loud, noisy scans, just a few targeted things, tactical techniques, will get you a lot of information that's more useful. So drilling down a little more into this particular example, this one target had an internal app which we discovered by doing some of these slow scans. And what they used this app for was software licensing and distribution. So every host on this large network used this application to get their software. There are something like 10,000 nodes using this. So we managed to get a copy of the software, and rather than do traditional, let's look for buffer overflows, let's look for other types of exploits, we'll reverse it and just look for standard sort of configuration issues. Well, what we found was they had a static administrator password stored in memory when this application was run. So every host on the network had the same admin password for a period of time. By using this password, we were able to own every host on the network without using a single exploit, just by taking a look at the application services that were available.
Kind of the key thing about application discovery is that if you're looking for different applications in the network, you're scanning ports, and you find something you don't know what it is, you just find port 1523 open, for example, which may actually be something. If you don't know what it is, that's your job to go find out what it is. In other words, go look for any kind of copy of that application. If you can figure out what application it is, get a copy of that application. And that's where a lot of pen tests kind of fall down, is you find out that, hey, they're running some custom web server, and you can't find a copy of that server in the next 20 minutes. So you don't really worry about it. But however, if you actually go through the effort of finding a copy of that software, BitTorrent, Donkey, whatever you need to do to find a copy of that software, to bring it down locally, tear it apart, and find a bug, that's how you're going to get in. So the point with the pen test is to break in. That's all there is to it. So as long as you keep that in mind and realize that the only scope that really matters is whether or not you're in or not, in some cases, and what they can prove later on in the court of law, that's what it comes down to. So in this case, it was finding a copy of the application, tearing it apart, finding the password, and then using that everywhere. And every one of those nodes could have been patched, and you still got access to 10,000 shells. So it's really effective.
Yeah, if you're just relying on well-known commercial vulnerabilities, many times you're not going to get in. The network's going to be patched, and you're going to be out of luck. But if you expand your scope a little bit and look deeply into the custom stuff that people are doing, you'll find ways to get in.
So a little bit of application discovery. A tool, we're going to talk about a lot of new tools that came out in the last couple of months because I haven't seen much noise about them on the list, and I think they're really great. One example of that tool is W3AF, which is actually the acronym for Web Application Attack and Audit Framework. What this tool does is kind of like a Python version of Metasploit for the web. And that's a really ugly way of saying it as a really cool tab completion command shell for doing things like directory brute forcing, finding virtual hosts, all the things we talked about earlier for finding information about applications and discovering custom applications, you can script using this tool for the command line. So like a lot of the best tools out there, it actually gets pretty heavy into scripting when you start extending it. Things like Scapy. This is kind of like the web version of Scapy for the folks here who have played with that. It's a really great tool, and I definitely recommend you get familiar with it if you haven't already, if you're doing pen testing for web apps. One thing I want to mention real quick is that Metasploit 3 has actually been extended to include what's called the scanner modules. And scanner modules are any module that includes the auxiliary scanner mixin. And what that gives you basically is you can write a really quick module, include the TCP mixin, include the auxiliary scanner mixin, and all you have to do inside your code is create a function called def run host. And inside def run host, you get an IP address, and if you do connect, it connects to a port, and it talks to it and does whatever you want to do. So if you find some custom application and you realize, hey, if I send these 4 bytes to it, I get back a version number, but you don't really want to go through all the effort of building a scanning framework for it and either writing in C or Perl or whatnot, and it's kind of a pain. You don't want to worry about having to set like doing CIDR mass parsing. I mean, all those different things that are part of most little quick scanning tools that are a pain in the ass to write, you can do just by using the Metasploit auxiliary format. And I'm going to pop off the slides real quick here and just show you an example of what that looks like. So first off, can anyone actually read the screen? All right, so let me try to make the font a little bit bigger. And that didn't work, so let's try that again. Let's see, Courier, console, something big. How about now? All right, great. So in the main directory, you can see there's scanner batch, scanner host, scanner range. Those are just example scripts that show how to either write a scanner that works off a single host at a time, a single range of hosts at a time, or a single batch of hosts defined by your module. And the neat thing about that is, even though it only works off one host at a time, one of the parameters that you get is the number of threads to run at the same time. So you can write a single host tool that basically connects to a service, sends some data, gets a response, stores it somewhere, but you can have it run against 1,024 threads at the exact same time. And you can use just basically normal stack routines, run as an unprivileged user, and quickly scan a huge network for a custom application. So don't let the fact that there's no tool out there for whatever application you're looking for keep you from running a scanner for it, or to keep you from finding similar information or similar data. The structure for it's really easy. We've got, at the very top, some basic boilerplate saying, it inherits from MSF auxiliary, includes auxiliary module, name, information, options saying we take a port value. Excuse me, that is VI. Oh, Vim, all right. Got it. There we go. Now I know how to do that. Thank you. Hey, I actually use Nirvana Editor. I don't use VI or Vim. Like, I'm one of those, I don't know if that's old school or new school, but I use a less TIFF-based editor still. So, anyways. So here we see we've got a little function that's 3 lines long called def run host, takes an IP address, prints out saying, hey, I'm working on this host. So pretty damn boring. So let's go look at a better example. Inside this directory, we also see there's a couple files called HTTP, MSQL, SMB, etc. If we look at the HTTP example of that, we have a version scanner, which is, see, look, I learned. All right. So you can see we include HTTP client mixin, we include the scanner mixin, in the run host function, which is kind of mangled because of the line wrap. But basically, we just do one call to send request URI/method get. You can see here, we don't actually set our host name anywhere. We don't actually do a connection call anywhere. That all happens for you underneath the scenes. So if you want to write a single host web scanner real quick,